just a quick review. So last year I put up a slide that said PDF. Okay, it started out with the PDF, and what I was really talking about here is when people see the word PDF, they know that they can use it everywhere. They know that they can print it. They know that they can create them. They know that they can read them. You can read them on your cell phone. You can, just about anywhere you see the word PDF, you know it. And you don't instantaneously think the word, you don't think it's Adobe, right? It's not coming to your mind Adobe. You know that it can be created lots of different ways and stuff like that. Similarly, I talked about Linux. Sadly, Linux just doesn't mean Red Hat. Right? Linux is everywhere. Linux is open. It's fully open. It's everywhere. There's lots of technology that uses Linux. Your cell phone, your desktop devices, your TV top devices, your cars. Everything's using Linux at this point. And again, it's not controlled by one company, and we're not locked down to just the ideas of one company. So the next thing I talked about is we got to do that for containers. We got to stop this concentration on only one way of doing containers in the world. And to me, that's always been the most disappointing thing about containers is that we're still doing stuff the same way we were doing it 4 years ago when the container revolution started. So this talk's going to talk about some things that we've done. I don't know if this is a US thing only. Do you know what a swear jar is? Okay, in a swear jar, a lot of families, when they have young sons, like mine did a few years ago, you'd have a swear jar. And if anybody ever sweared, they'd have to put a coin into the swear jar. In the US, it usually be a quarter. So what I'm going to do today is I'm putting out the Brno version of a swear jar. And if I say the D word, I got to throw a coin in it. Okay, so if you guys hear me say the D word, tell me to put something in the swear jar, okay? So what do I need to run a container? Okay, when I run a container, I need to identify what the hell a container is. Okay, and when most people talk about containers, they're talking about these things that exist at a container registry. Okay, they're a definition. So if I say run a Fedora container on my system, where does the Fedora container come from? What is the Fedora container? Well, a container is a Docker image. Okay. And that's what you guys understand. But nowadays it's an OCI image, right? There's been a standardization body on it. But it's basically a definition of this object that really it's a tarball in a JSON file. Okay, you take a rootfs, basically equivalent to what looks like / in your operating system. You tar it up, and then you create a JSON file associated with it. The JSON file has things in it like, what's the entry point to my container? What environmental variables do I want to be set by default when you run this container? There's probably about 10 or 15 fields that are in this JSON file. Well, a couple of years ago, we standardized on, we got together with a whole group of companies, including Red Hat, IBM, Microsoft, Google, Docker, CryOS, and they got together and they standardized on what this image format was. So now we have an image format that defines what these container images are. Okay? So that's what the OCI image format is, kind of cool. The next thing I need to do when I want to run a container is I have to get it off of the container registry and pull it to my host. Okay? I need to be able to do that mechanism. How does people in this room do that now? How do you pull an image from a registry to your host? There's going to be a lot of quarters coming down in a minute. Okay? You do a pull. Okay? You do a D pull. Okay? That's the only way. To get a tarball off a container, you know what a container registry is? It's a web server. Okay? You should be able to use curl to pull these things down. Right? It's just a web server. Okay? But we built this protocol around it, and we pull these things down. But the only way to do that is to do a D pull. Okay? Why is that? Why are we stuck in that world? what we've done is created a new library called containers image. We created it about a year ago, or a couple of years ago, and now we're using that. And we're going to talk later on about a tool called Scopio. Scopio has actually become, out of all the products that we've been talking about here, Scopio is probably the most popular, and it's used by lots and lots of people. And it's based on top of containers image, and it's able to move container images around. You can actually, from a Mac, copy out of one web service called the container registry and push it to another web service called the container registry. Right? You can do it from Windows. You can do it anywhere. Right? This is a simple protocol for moving containers around, and that's an implemented containers image. So after I pull the image to my host that I want to run it from, I have to basically disassemble that container image onto my system into some kind of storage. Now, I mentioned that a OCI image is basically a tarball and a JSON, but it's actually more than that because there's a layering system built into it. Okay, so I basically get a rootfs, I tar it up, I create a JSON file. Now I want to get another layer, so I install more software on top of the existing rootfs. I get a tarball of the differences. I make a new JSON file that might change some of the fields in the original JSON file, and then I tar that whole thing up again, and that's the next layer. And then if I want to create a third layer, I create another tarball of the differences and another JSON file. So I keep on creating these tarballs, and that's really what an OCI image is. But when I pull that down, I want to be able to take that and disassemble it and put it onto my disk. But I want to maintain those layers. So I need a layering file system, often called a copy-on-write file system, COW, copy-on-write. So I need a mechanism to do that. Luckily, over the years, we've developed all sorts of copy-on-write file systems to support this. Okay? And the latest, the hot one right now is overlay file system. But we have Device Mapper, ButterFS. There's UnionFS, which only works on Ubuntu. So there's been lots of these technologies. A couple of years ago, basically about a year and a half ago, we sucked all that stuff out of the Docker program and built container registry. So we took a lot of the code that we had donated to them and then pulled it out and created container registry, container storage. So now we have a library that actually allows us to basically do copy-on-write file systems, to do copy-on-write and basically to disassemble the OCI images onto the storage. And then the last thing, so I know what an image is, I copy it to my host, I disassemble it onto the host, or basically depack it onto my host. Now I have a rootfs. Now I want to run it. How do I run a container? Okay, the way you run a container on the host is basically it's been standardized with a thing called Open Container Runtime, OCI Runtime Specification. So what the OCI Runtime Specification specifies that I have to have one of these rootfs's, and I have a JSON file that I create that defines what I want to do with the image. It usually the tools that create this take the JSON data out of the image, and combine it to whatever the user inputs. So when you execute a command using the D word, you're actually creating a JSON file, putting it on disk, and then you're executing a program called runc, usually, to run the container. So runc is the de facto implementation of the Open Container Initiative runtime spec for running containers. Did I mention anything in this talk? So you can run a container with just those steps. What's missing from it? Why do we need big fat daemons? Okay? If you look at the way containers have evolved right now, all we have daemons popping up all over the place. To run a container from OpenShift, OpenShift talks to Kubernetes, one daemon. Kubernetes talks to the D word, two daemons, the D daemon. The D daemon talks to container D, three daemons. Container D then launches runc, and runc runs the system. Why do we need that? Let's step back. What is a container after I launch it? A container is nothing more than a process on a Linux system. Every process on a Linux system, I would argue that every process on a Linux system is a container. Okay? So often people talk about containers, they look at three things. I have C group, or resource constraints on it. Every process on a Linux system is in a C group. Okay, resource constraints like memory utilization. So every process is in a C group. The next thing you look at with containers is security separation. Every process on a Linux system has capabilities associated, has ownership, has SE Linux labels. If you're running on an SE Linux system, they all have it. So every process is in a container. The last one is these things called namespaces, these special things called namespaces. But if you went to proc 1 status on a proc 1 NS on a Linux system, you would see that every process is in a namespace. So when people talk about containers, sort of the standard containers, they're just talking about processes on a Linux system. Several people in this room, my model up here who's not paying attention, has a containers, a Linux and Linux is a containers t-shirt on. That is the definition of a container, okay? So containers are. So when I put these containers and they end up in this weird world, what's happening? We're just going into the kernel and modifying some of those fields. We're modifying the security attributes, we're modifying the namespaces, and we're modifying the C groups. But they end up being standard processes on the system. So there's nothing required of any special daemon, there's nothing required of any special process to do that. A lot of these technologies have existed for over 10 years now. But yet we're getting into this world, we have to have daemons, we have to have daemons. Every time we turn around, we have to have a daemon. So I want to do things without having to require daemons. So let's look at what does OpenShift and Kubernetes need to require to run a container. Well, a little history. A couple of years ago, Kubernetes first came out, and all they did is they took and wrote a whole bunch of Docker code into Kubernetes. So it was just loaded with all sorts of interfaces on how to run that. CryOS came along, and CryOS said, you know, we have this other container runtime called Rocket. And we want Rocket to play in the Kubernetes world. So they wrote huge patches to Kubernetes and said, merge this stuff into your code. And at the time, Kubernetes said, we're not that crazy about having huge if then else statements. So I didn't want to have if you configured, Kubernetes do it this way, if you configured the other guy do it this way, and then some third party is going to come along eventually and say, I'll do it this way. So Kubernetes pushed back and said, instead of us taking every single container runtime and merging it into Kubernetes, we're going to turn it around. And we're going to say, we're going to call out to an API. And that API, anybody that satisfies that API, Kubernetes will be willing to work with. And that API is called CRI, Container Runtime Interface. And that's what they defined. And Rocket at the time went out and created Rockinettes, which is basically Rocket front-ended by a CRI interface. So the guys on my team, Ronald Patel and Antonio Murdaca, said, actually I'm jumping ahead. Let's finish out. So CRI got invented, and Kubernetes tells, so basically what Kubernetes, when OpenShift wants to run a container, it tells Kubernetes to run the container. Kubernetes then calls out to a CRI to run a container image, and it basically says, run this image. That image is defined as an OCI image, and then CRI needs to pull that image from somewhere. Guess what it uses? Container's image would probably be a way of doing that. Next, it needs to copy it down and put it onto a copy on write file system. And lastly, it needs to execute the container. So pretty much matches up what I just talked about, right? So the guys on my team, again, this was last September, a year ago September, started working on this thing, their own little project called CRIO. So CRIO is an OCI-based implementation of a Kubernetes container runtime interface, but the scope is totally controlled by the CRI. We don't put anything into Kubernetes, into a CRIO that Kubernetes doesn't request. Our only supported user is Kubernetes, nothing more, nothing less. Let's look at this another way. CRIO loves Kubernetes, okay? CRIO has seen some pretty girls in its day. They've seen Mesosphere. She's a cutie pie. But we ignore her. She's seen Swarm. We ignore her. She's seen the new chick on the planet, Moby. We ignore her. We see the old chick. We ignore her. So CRIO is all about Kubernetes. Bottom line, It does not have any of the APIs of the other guys in it. If Kubernetes says we're going to go with this version, this way, CRI implements it, we implement it instantaneously. So let's look a little deeper into what CRIO is. So CRIO uses all the containers, image container storage that I talked about earlier, launches the same run C that the other container runtimes are using, and uses standard OCI images. It can run anything, any of the images that are available at Docker.io. Basically will run those, but it actually needs some additional tools. So remember I talked about when I run a container, I need to create that specification on disk before I launch it so the run C can run it. So there's a library called OCI Runtime Tools that you can use to actually generate that OCI runtime specification. So it takes advantage of that. Again, CoreOS developed this thing called the CNI, and it's basically the same tool, same ways that Kubernetes sets up networking is the CNI, and CRIO uses the CNI to set up all its networking. And it's been tested with Flannel, Weave, OpenShift SDN. Pretty much everybody right now is moving towards the CNI-based networking standard, so you can swap them in and out. And lastly, when you run containers, you need a tool that actually monitors the containers. So you need to be able to start and stop your daemon and basically leave the containers running. So there's a tool, a small C program that we've written called Conmon that monitors your connections to your containers. So it does monitoring, logging, handling of the TTYs, things like that, so that basically you can bring up and down the CRIO daemon. And you notice that, isn't that sad that I'm talking about a daemon after saying no big fat demons? But this is a skinny daemon. Okay, that's my excuse. It's just a skinny daemon. Okay. But basically, Conmon is the tool that comes up and down. Conmon monitors, and that allows us to bring up and down the daemon at any time. So let's look a little closer at CRIO's infrastructure. So everybody here know what a pod is? So we often talk about containers, but pods are sort of a slightly higher level concept that Kubernetes has defined. And a pod is basically multiple containers inside of a same running infrastructure. Usually pods share things like the IPC net, PID namespaces. PID namespace is more optional, but in the same C groups. So they live on the same network, and they really move around. So these two or more containers can run. But often pods are just a single container. So in Kubernetes, they define this thing called an infra container, often called a pods container. That's sort of the initial container that goes out. It really does almost nothing other than hold the network open. And then you attach other containers to it. So a standard pod definition would look like this, and we'd have 3 Conmons running. Conmon is a very lightweight C program, so it actually uses almost no memory running on the system. So it's really, really nice for running lots and lots of containers. Going up one level higher, you see that previous slide is up at the top. You see multiple pods running, one with 2 containers, another with 1. And then we step down, we talk about the kubelet here. The kubelet's talking that GRPC, but the GRPC really is just CRI. So it's talking the CRI protocol to the CRIO daemon. CRIO daemon is using the image service to pull down the images. That's container's image. Uses the runtime service for running them. OCI generates CNI, those things I talked about, and it uses a storage library underneath. So that's a whole infrastructure of what CRIO is doing. So CRIO, if you want to get a pull request into CRIO, you better be ready to wait. Okay? Every pull request, you want to change the man pages, we run 500 tests before it gets into CRIO. One of the reasons we wanted to make this thing as robust as humanly possible is all the problems that Kubernetes has had in the past running on the D daemon. Okay? We wanted to make this thing as rock solid. So we run every test that Kubernetes or anybody else has written concerning running a container runtime underneath it for every pull request. So no PRs are going to get merged without that. My engineers, they wanted to have a 1.0. So we released 1.0 last fall of CRIO for our OpenShift 3.7, and it was supporting of Kubernetes 1.7. I hated the fact that we called it 1.0. Okay? From now on, every single CRIO release is going to be named after the Kubernetes release. So if you want to run Kubernetes 1.8, you get CRIO 1.8. If you want to run 1.9, you get CRIO 1.9. If you want to run 1.10, there's obviously some people are not following along well here. You run CRIO 1.10. So as of Kubernetes 1.8 support, we have 1.8 CRIO. This is available, so 1.7 is available in RHEL right now as tech preview with OpenShift 3.7. CRIO 1.8 is now available for Origin 3.8. There has not been a shipped version or supported version of OpenShift for 3.8. It supports Kubernetes 1.8. And guess what? It is running, OpenShift Online is running on top of CRIO, okay? It is rolling out, several nodes are now running it and is slowly rolling out. So we're moving all of OpenShift Online on top of CRIO and moving the D word out. As of the next version of OpenShift that's going to ship, it's going to be 3.9. It's going to be based on Kubernetes 1.9. And which version of CRIO will we use? Don't ask that guy in the corner. It's going to use 1.9. Pretty simple, right? So 1.9 is available now, and our goal, so as of 3.9 of OpenShift, which comes out sometime early spring, we're planning on fully supporting CRIO in RHEL systems. The D word will still be the default. CRIO will be optional. As of 3.10, we want to flip them. So we want the default to be CRIO at that point, and then you'll still have the D word as an option. So who's working on CRIO? Well, right now, the major contributors are Red Hat and Intel. We also have contributors coming in from Lyft and SUSE and a bunch of other companies. And as I said earlier, we're really proud of this. We're now powering OpenShift Online, and we're hoping that our admins have a better experience than they've had over the last couple of years. I can't tell you who says this, but this is my favorite quote about CRIO so far. And that is, we asked one of our contributors, why haven't we heard about them using this thing in production? And they said, why would we talk about it? It just works. Okay? And that's really what our number one goal with CRIO is. We want to get rid of the drama of this thing, right? Just to get the thing to simply work. And we want to make running containers in production boring. They're just processes on a Linux system. Let's make them boring. So I now work for OpenShift. And so what OpenShift wants, I got to provide. So what else does OpenShift need? So those of you that played with OpenShift, OpenShift is not just running containers inside of Kubernetes. We needed some other stuff to do it. Main thing we needed for OpenShift is the ability to build containers. Okay? I talked earlier about what I'm disappointed about in the container world. Anybody in the room tell me, how do you build one of these container images? How do you build a tarball with a JSON file? Anybody? What's the command you use? Huh? You use dbuild. Good. Someone doesn't want to spend any money. Okay, here we are several years later, and the only way to build a tarball in a JSON file is to use a big fat daemon, right, to build a thing. And it's just one way to do it. What's the tool? What's the definition of an image? It's a D file, right? There's only one way to define these things. So isn't that sad? I think that's incredibly sad. So last year, this is Nalan Daibai. He almost made it to here and got stuck in Boston because of ice storms. But last year, Nalan was here, and I was talking to him. He's the guy that's in charge of container storage. And it was actually probably on this very day, I sat down with him and I said, you know, what we need is like this core utilities program for building containers. And he said, well, what should I call it? And I said, well, why don't you just call it Builder? And at the end of the day, that very day, he did a lightning talk. And he created Builder. Good. It's a good thing he didn't end it, by the way, the Boston accent. If that was B-U-I-L-D-A, the way I would pronounce it would be builder. Okay, so Bostonians replace A's with ERs and ERs with AHs. But I'm going to ruin everybody that's looking at that logo right now. If you look at that logo, that's a Boston Terrier, right? That's the name of the dog. And the first thing that was tweeted after that went out is, that's a Boston Terrier wearing underwear on his head. So that's the original logo. We've actually fixed it so it looks more like a hard hat. But anytime you see that now, you're going to think about tighty whities on a dog's head. So Builder, again, I defined it as core utilities for building containers, simple interface. So the first thing we need when I want to build a container on the system is, right, I have to pull it off of the registry. Right, I have to pull the container off of the registry, and we all know what tool I'm using to pull it. I'm using containers image. So we built a command line that just said builder from Fedora. It pretty much follows what the the Docker file syntax. From the system, basically we're looking at equivalent syntax. So that pulls the image down to the system, and then you want to mount it. So you want to mount it, so you just do a builder mount, and that actually mounts that container image onto or gives you back the mount point of where the container image is mounted. Segue. Do you know about this command? This is worth a quarter. So this is a command called Docker copy. Guess what it does? It copies contents out of an image onto your host, and it copies contents from your host into the container. Okay, they had to build a separate code to do that. So I wanted to follow along with that, and so I decided to build a tool called copy, CP. And I built it. I put it into the core utilities package, but I contributed it there. So I built this tool called copy, and I'm able to copy source from the image into the container, and I'm able to copy content out of the image onto the host. I saw that, and I'm going to go into my biblical thing then, and I saw it was good. So I decided to build another tool. I built DNF. So I built this tool called DNF, and sometimes I used to call it Yum, but I think I'm going to call it a Yum again in the future. What it does is it allows you to pull RPMs from the RPM registry and install them, and actually you can reroute them to put them into a mount point. And then you can just install all these packages into it. So saw that, it was good, and decided I might build another tool. I built a tool called Make. So after building Make, I said, I'm going to put a thing in there called install, and then I'm going to do destir, and I'm able to redirect content into the mount point. So I can use all these tools that I built to basically put content into the container. This gives me a really nice effect over doing containers the way we've done them in the past, is that I don't have to have make, DNF, copy, compilers, everything else inside of my container image. The only thing I want in a container image is Apache, right? I don't want to have all the tools to build it. Some ways way we ship container images right now is like if you shipped a GCC program, you would have to ship with it make, GCC, all the shared libraries, all the .h files. Everything would have to go. So your RPMs would swell to huge amounts of size. Okay? There's a lot of people that I deal with in the Defense Department who want almost nothing inside of the containers because they consider any tool that's inside the container to be an attack vector on the host. Okay? So this is a really cool way of building containers. So we have to do a couple of things. We have to configure that JSON file associated with the image. So there's a builder config, and you're able to specify all the options that you want to have associated with that JSON file. And lastly, you want to be able to push it to a container registry. So you're able to do, that commit actually completes the process, and then I'm able to push the image out to a container registry. And we can push to any kind of container registry. Again, we're using containers image to do all this stuff. Dan, wait, I didn't swear. Did I? No, I didn't say it. Are you asleep? You're supposed to read that.
What about a Docker file?
Oh, very good. I didn't think you'd ask that question. and you owe me a quarter. So Builder supports the D file format. Okay, so we also added, we knew that people use this artifact to build container images all over the place, so we wanted to build into Builder the ability to use those, and we called it Builder build using D files. And it basically follows the same syntax that you use when you do a debuild of the system. But obviously, engineers are lazy. We don't want to type that many letters. So Anheuser-Busch didn't give us approval for this name, but we call it BuilderBud. So BuilderBud will support, has full support for the D file format. What about other formats? Okay, what you might want to ask is, did I create a Builder file? And I did. I wrote an unbelievable program that you can use to create your languages for building these things, and I called it Bash. So I introduced Bash to the system. And you can use Bash to actually encapsulate the process of building one of these containers. So now with Bash and support for D file, we can build in 2 different ways. Okay? We want to allow others to take advantage of Builder for building containers. So we want high-level tools. If other people want to develop languages and ways of building containers, we want to take advantage of them. And again, I work for OpenShift now. So we're working to get OpenShift to use Builder for source to image. So anybody who's played with source to image is basically, most developers shouldn't know they're building containers. They shouldn't care. Really what they want to do is they want to build a web app. So really what they want to do is git check-in, and then magic happens behind, and the stuff becomes software on the field. So what OpenShift does, they call it source to image, but as soon as you do a check-in, all of a sudden all the turning happens in the back, and a container runtime pops out the end. So with source to image, sadly, OpenShift right now is using the D word underneath the covers, because that's the only way, 4 years later, to build containers image. So we want them to start using Builder, and we're working on it. We're also meeting with the Ansible containers, who are also using the daemon underneath the covers to build. But if you want to specify an Ansible playbook for how you want to define your container image, we should be able to use these lower level tools to build container images. So what else does OpenShift need to build containers? Well, really, we have enough. The problem is debugging, or figuring out what's going on in the system. So the way, if you're running a Kubernetes environment right now, you need to, sometimes things go wrong, and you need to get onto the host, and you need to run commands on the host to sort of diagnose it. Most people right now are using the D commands to look at the system, list out the images, list out what's happening on the system, look at the container storage, things like that. So that's how they diagnose. But if we're getting rid of the D system from here, we need another tool. So how many people in here have ever heard of KPod? Okay, a few people have heard of KPod no longer exists. It's now called PodMan. Long live PodMan. PodMan is a tool for managing pods and containers on your system based on the Docker CLI. I'm going to run out of coins. Okay, so we basically said we wanted you to have your muscle memory. We wanted to implement as many of the commands that you use for running and managing containers based on that CLI. So if you want to list all the containers on your system, you do a podman ps-a. If you want to run a container directly, you use a podman run TI Fedora Sleep 2000. That's an example, very similar to the D word. If you want to exec into the container, you do something like that. If you want to list out the images, pretty much, if you looked at it, every command that you used to in the D word, we now have available in PodMan. PodMan is just about to be released to Fedora. It's available at the repo called LibPod under Project Atomic, and it is really cool. It works just like it, but it's really different. When you use the D command, you're actually doing a client-server operation. So you have the client basically talks to a server and runs it. So anybody that's ever tried to run a container, put the D command inside of systemd, when they launch, they think that the container ends up being like a grandchild of systemd. It's not. Well, it is, but it's not your grandchild. It's the Docker daemon's grandchild. So anytime you run, so certain things, because of that break, so there's certain things that you might want to do through systemd do not get passed down to the child. If you use PodMan, it works the way standard Linux commands work, in that the child, the container ends up being a child of its parent process. It's a fork exec model. Okay, there's no daemon in the middle. There's no client-server operation. That means if you have C groups constraints on the client, they end up applying to the server. It works all the way down the stack. So the last tool I'm going to talk about is the granddaddy of them all. It's called Scopio. It was the first tool that we introduced. Scopio means remote viewing. And it was invented because we wanted to be able to go out to a container registry and actually pull down the JSON file. Some container images can be massive. I'm not going to pick out anybody, but there's Red Hat images that have to do with middleware. I'm not going to say the name. That are like 1.5 gigabytes. The only way for you to look at what's going to happen when you execute those images is actually to pull 1.5 gigabytes to your host. So we offered a patch up to the upstream D team to basically do a de-inspect -- remote. It got turned down, and they told us at the time that we shouldn't do that. We should say it's just a web service. Why don't you just implement a simple command to do it? So we invented Scopio basically to do that, to look at the JSON file without actually pulling the image to the host. Antonio Merdaco, who's somewhere in the room here, wrote that. Eventually, we decided to split it into a separate library. So that's where containers image came out of, and then Scopio became a CLI in front of that. So Scopio is actually being used everywhere. Scopio is probably the most popular of these tools. Now, what we see, we're getting lots and lots of pull requests from different companies, very strange companies that are taking advantage of containers image and taking advantage of Scopio for moving these containers images around. So you think about a lot of companies out there, they want to grab stuff off of the big container registries in the field, and they want to move them inside, or they want to move them so they're more locally to different geographies and stuff like that. And Scopio is a great tool for doing that. So Scopio, and if you saw Antonio's talk yesterday, Scopio is also tied into our image signing process. So with Scopio, you have commands like this. So the first one is what I talked about originally, is if you want to go inspect an image just to see the JSON file associated with it, you can do that. But then you can do much greater things like actually copying stuff off of containers, off of container registries. And then you can do things like you can actually copy them and translate them into OCI images. If they're V1 images or V2 images, we can actually copy them to directories. Pulp and Satellite are looking at basically moving content around using Scopio back and forth. You can actually delete images off of container registries. So Scopio is a really cool tool for interacting with container registries. You can actually use Scopio to copy directly into your container storage so that CRIO and PodMan and Builder can all use the content. You can copy directly into the Docker daemon and be able to run directly there. So Scopio actually is a really cool tool for managing these container images that may be preloading. So that's it. Those are the technologies that we have. All of the technologies are available here. All of them are in different states. Scopio, again, is the oldest. CRIO is just getting to the full supported side. Builder is supported. It's available in RHEL at this point. libpod is the parent directory for PodMan. libpod, our goal with libpod is to eventually build out the library in such a way that other teams that want to just manage pods, instead of just managing containers, would be able to use libpod. Libpod, our goal is to get libpod integrated into Builder, containers, get it into Builder, PodMan, and to CRIO to get them all unified. But the really cool thing here is that PodMan, Builder, and CRIO, and Scopio can all use the same storage, can all pull images. So as soon as you pull an image, you can build an image with Builder, and instantaneously it's available to Scopio to be able to copy out. It's instantaneously available to PodMan to run. It's instantaneously available to CRIO to run. So as these tools are all integrated, but we don't have to go through one big fat daemon. So they all work using this thing that I also invented called file system storage. Okay, so any questions? Yes? I believe it's you, Antonio, you here? I believe it is. Anybody from OpenShift able to tell us that we're using CNI right now? Yes. Yes, we are. Yes. Right. Okay, so there's a tool called, actually, we're about to package that up. So there's a package, the question was, there's a Kubernetes, another Kubernetes incubator project is called CRI-CTL. So it's basically a front-end tool for talking to CRIO daemons, for CRI daemons. So you can, we actually use CRI-CTL for testing out it. One of the differences between PodMan and CRI-CTL is CRI-CTL actually talks to the daemon, and then the daemon does the management of the containers. PodMan's coming in the back and looking at what's happening on the system from behind. And it's really good to have both of these, because oftentimes what you'll see is the daemon gets hung up for some reason, and you might want to use PodMan to come in and look at what's going on in the back. But if you want to implement the protocol to talk to a CRI daemon, then you can use CRI-CTL. Our plan is to ship CRI-CTL. We actually had, when CRIO was being developed, we created a thing called CRYO-CTL, which we now have abandoned, and now we're moving to CRI-CTL. So we hope to ship CRI-CTL very soon. Yep. Right, so right now we're not building a special daemon to be able to manage any of this stuff. If the community wants to do that, we're willing to look at that. There was a lot of talk in the meetings leading up to this about potentially putting some kind of API daemon in to be able to do all this stuff. But right now, all we wanted to do was, again, our main goal was CRI, but then to add additional tools. But right now, we don't have any special daemons listening for other types of activity. Our goal is not to replace the Docker CLI. Thanks for costing me money. Yes? I cannot hear you. Okay, so Conmon doesn't store anything. Conmon is storing stuff on files on disk, but when CRIO comes back up, it's using Prometheus and stuff like that to get the data back. So the data is being provided by CRIO to provide data back. But everything basically, Conmon is basically channeling everything to disk. Anybody else? Yep.
Our old client stack now running basically with deconfiguration. Do we have official migration path already for the clients who want to migrate? Having in mind, like, we have on the field, we know how to configure pool, Docker, and all those.
Right. I mean, we're going to be providing similar to it. I mean, from an OpenShift point of view, it's all going to be built into the OpenShift Ansible scripts. But we're going to follow the same thing. Our plan is not to allow you to help you migrate, migrate the scripts, but they're going to work very similar, right? Containers are stored in VirLib containers as opposed to VirLib Docker. Yeah. Right. I mean, yeah, you could actually have a fully running system and then use Scopio to copy out of one storage into the other storage, stop one and start the other, and it should just work, instantaneously roll it over. So you can move your images around if you wanted to do that. Anybody else? Okay, anybody else want to contribute? I got to find someone to take this charity now. Oh, who's? Well, the funny thing is both of us are contributing to each other's, but not directly. They watch what we do. They take our stuff, put it into theirs. We watch what they do. We take their stuff and put it in ours. So it's open source. Ain't that awesome, huh? So if they have a good idea, we're taking it. We have a good idea, they're taking it. The bottom line with CRIO, though, as far as I'm concerned, is what we talked about earlier. You shouldn't care. No one should care what's happening on that. Quickly, I'm going to talk about one other thing. Giuseppe, are you here? Giuseppe's way up in the corner there. Okay, so Giuseppe, who obviously needs better things to do. At Red Hat, we have 2 weeks off at Christmas break. And he decided to go out and take run C and write crun and actually use C to implement the entire OCI image spec. So over Christmas this year, he did that. We're just starting to look at that. And it's interesting that run C, which is a Go library, manipulating the kernel is actually kind of funny. The code they had to write is kind of a little iffy. So it's interesting that as we have OCI runtime specs, and I should have mentioned some other things along the way, we can actually use alternative runtimes. So we can use other runtimes besides run C. Matter of fact, Intel, being our largest contributor to the project, is working on Clear Linux containers, which has since been named Sukata. And right now, if you went to Microsoft Azure and you wanted to run Kata containers, you'd be running on top of CRIO, because CRIO is the only one that supports Kata containers. So right now, in the entire CRIO spec, you can specify different container runtimes. You can run what they call trusted and untrusted content at the same time. You can set it up so it'll run, say, run C in a trusted environment and run Clear containers in a untrusted content. So with that functionality, so our goal is to be able to do multiple ones. So what we're going to take a look at what he's done with crun and probably start experimenting with it and putting that in as yet another alternative. Now, whether or not Red Hat ever ships it or supports it, I don't know. It'd be nice to see if we get other contributors. But again, the whole idea here is to be able to pull different parts of the operating system and be able to assemble different things into this thing to really run Linux processes on Linux systems. So thanks for everybody coming, and hope you enjoy the rest of the show.